All right, so same deal with the inverse tangent function. On the left, you find the graph of tangent and all its repeaters. And notice that a couple special points are labeled here. Pi over 4 comma 1, 0 comma 0, and negative pi over 4 comma negative 1. And again, we're going to have to restrict the domain so that this thing has an inverse. So we're going to use, notice we keep using the interval that includes 0. That's not a fluke, if we can help it. So we'll talk about that in a little while. Because the first quadrant is kind of where all trig functions are happy. So we try to use that first quadrant whenever we can. Anyway, so we're going to restrict the domain to, now notice, I can't include pi over 2 this time because that's where the asymptotes are. But I can approach pi over 2 from the left, and I can approach negative pi over 2 from the right. So the domain restriction actually is negative pi over 2 to pi over 2, but not including the endpoint, so with parentheses. And just remember what the inverse tangent means. If I'm plugging something into the inverse tangent function, I'm saying, here's the ratio, give me the angle. And what that ends up doing is notice the notice the range of this function is all real numbers. This thing just keeps going up, 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 and away, and down, down, down. So when we go to the inverse, everything flips. Okay? So the domain is now negative infinity to infinity. The range is now negative pi over 2 to pi over 2. And we have horizontal asymptotes when y equals plus and minus pi over 2. So this is an interesting graph. So let's look at exact values here. So inverse tangent of negative 1, well, what do we take the what do we take the tangent of to end up with negative 1? Remember that tangent of pi over 4 is 1, so that means tangent of negative pi over 4 is negative 1. So the answer here is negative pi over 4. Side note, if you put your calculator into degree mode, you should get that tangent inverse of negative 1 is negative 45, which means negative 45 degrees, which is negative pi over 4. So you can use degree mode to your advantage here. I just wouldn't do it if you're going to be graphing anything. Okay? Just like inverse tangent of square root of 3, well, I know that the angle that corresponds to square root of 3 is, I could call it 60 degrees for a moment here. I'll say that that's pi over 3. So that means that this is pi over 3. So if you're in degree mode, you're going to get 60. And if you're in radian mode, you're going to get pi over 3. Now, interestingly enough, inverse tangent of 3.72. Now, we don't have the restrictions that we used to have. So let's just find that on our calculator here. So I just want to check my mode. I was in degree mode. Okay, so radian mode. If I do inverse tangent of 3.72, I get 1.308. And if you're curious, I'm just going to multiply that by 180 over pi. Whoops. I wanted 180 over pi. There we go. That's about 75 degrees. So there's something to notice there. Now, since we don't have all the domain and range quirks in the tangent function, if you apply the tangent to the inverse tangent, you get x. But if you apply the inverse tangent to the tangent, you're only going to get x if your angle is between negative pi over 2 to pi over 2. So this is the one to watch, because when you take the inverse tangent of something, your answer is guaranteed to be between negative pi over 2 and pi over 2. When you take the tangent of something, your answer can be anything. So let's look at a couple examples here. Tangent of the inverse tangent of 4.1. Well, that should be 4.1 by the property. Let's just double check this. So tangent of inverse tangent 4.1. Make sure all the parentheses are there, and yes, we absolutely get 4.1. Tangent inverse of tangent of pi over 5. Well, since that is on the magic interval between negative pi over 2 and pi over 2, I should be safe in writing pi over 5. Now let's double check that with the calculator. Inverse tangent of the tangent of pi over 5. Okay, I get a decimal, but I'm just going to double check that that's equal to pi over 5, and boom, there it is. So we're good. Now, as far as tan inverse of tangent of 2 pi over 3 goes, We're not going to get 2 pi over 3 because that is not on the interval negative pi over 2 to pi over 2. So what do we do there? Well, we could work it out by hand if we want to. Notice that the tangent of 2 pi over 3, well, let's see, that's a second quadrant angle. Reference angle is 60. That should be negative square root of 3. So now we're looking for the inverse tangent of the square root of 3. And I'm sorry, negative square root of 3, that should be negative pi over 3, which is negative 60. Because again, you want a fourth quadrant version of that angle because inverse tangent only returns quadrant 1 and quadrant 4. So now that we've seen all three trig functions, we kind of have our big picture here. We can also talk about just finding random exact values here. So that's what we're going to do next to pull everything together. Hopefully this is making sense so far. I thank you for watching.